Okay, so 6, you had x, y equals negative 15, and then 4x plus 3y equals 3. So I want to solve, you have to solve for one of the variables in the top, and it doesn't matter which one you pick. If I did x, it would be negative 15 over y. If I did y, it would be negative 15 over x. So let me see which one I did in the work. I did x equals. So x would equal negative 15 over y. And then I have to take that and I have to plug it in to the x. So I'd get 4 times negative 15 over y plus 3y equals 3. And then I'm going to multiply 4 over 1, negative 15 over y. This would be negative 60 over y plus 3y equals 3. Now I got to get that variable out of the denominator, so I'm going to multiply everything by it. These cancel. I get negative 60 plus 3y squared equals 3y. As soon as you see the y squared and the y, and it would have happened if it was the x too, I know I have to get everything to one side and I'm going to end up factoring. I like my squareds to be positive, so I'm going to move the 3y over here and rearrange it. So it's 3y squared minus 3y minus 60 equals 0. Now, I can divide everything by 3, make my life a little bit easier, or you could have factored as is, but if you divide everything by 3, and I can only do it because it's equal to 0, and I also divide the 0 by 3, I get y squared minus y minus 20 equals 0. And then I'm going to factor that. Factors of negative 20 that sum to negative 1. Good. And then I'm going to split and solve. And I get y equals 5 and y equals negative 4. And then I've got to go back to either original. So since this is already solved for x, I'm going to plug it in there. If I make y 5, I need to make y 5 and I need to make y 4. Negative 4, sorry. So when y is 5, x is negative 3. And when y is negative 4, x is 15 over 4. Joey. So 11, anytime there's fractions or decimals, my goal would be to get rid of them. So like the fractions, I'm going to look at the top one and see what's the least common denominator. It is 10, so I want to multiply everything by 10. So this whole thing gets multiplied by 10. So it'd be 10 times x plus 6 over 5 plus 10 times 2y minus x over 10 equals 10 times 1. Don't forget to go all the way to the other side of the equal sign. That's the biggest mistake people are going to make. So then the 5 cancels into the 10, and it becomes 2, and I distribute that. 2x plus 12. And then the 10 cancels. If there was a minus in the front, I would distribute the minus, but it's just plus, so it's plus 2y minus x equals 10. From here, if you want to combine your like terms, the 2x and the minus x would be x plus 2y, and then I can even move that 12 to the other side, and I get negative 2. That's the new top one. Then I'm going to repeat that whole process with the bottom one. So I'm multiplying times its least common denominator, which would be 20. So it's 20 times x plus 2 over 4 plus 20 times 3y plus 2 over 5 equals 20 times negative 1. Yep.
So what about when you did x plus 6 over, is that over 8?
Mm-mm.
Is that over 5?
It was 5. Yeah. So then 4. It's okay. 4 went into 5, and then I distributed it. 5 goes into 24 times, and I distribute that. 12y plus 8 equals negative 20. combine your like terms this time. There's a 5x plus 12y. This would be 18, and I can move it to the other side. And I get negative 38. Now, those are the two new equations after I get rid of the fractions. So 5x plus 12y equals negative 38. This is the system I'm working with now. All right, if I wanted to get rid of the y's, I could multiply top by negative 6. If I want to get rid of the x, I could multiply by negative 5. Negative 5x minus 10y would equal positive 10. These cancel. 2y equals negative 28. Divide by 2. And y equals negative 14. Then I got to take and plug that back in. You can plug it back into the beginning where the fractions are, or you could plug it back into the new ones that you modified. This one is definitely easier.
Is that not negative 38?
Is what not negative 38? Are you sure?
I can't read the right one.
This, the left one, you mean? This one?
That's negative 38.
It says 5x plus 12y equals negative 38. It's this. That's where it came from. All right, I'm plugging the y into x plus 2y equals negative 2. So x plus 2 times negative 14 equals negative 2. X minus 28 equals negative 2. Add the 28 and x equals 26. So then my coordinate point would be 26, negative 14. So with exception of your word problem, every answer, and the matrices obviously, needs to be given in coordinate point form. No x equals y equals, don't make me hunt for your answer, okay? It needs to go on the line and it needs to go in coordinate point form. Okay, so it said substitution and then it said graphing just to check it. You don't have to. You're going to have the option of solving it however you wanted to. So if you could choose, how would you have solved this? By which variable? Why would you do that? If I was in an isolated variable, I certainly wouldn't start with the ones that have coefficients, right? Yeah, I would either solve for x or solve for y. Because y is negative, I would solve for x. So I would do 13 plus y. Maybe that's why it went south. I would try to avoid that in any way, shape, or form. And you'd get 3 times 13 plus y plus 4y equals 4. 39 plus 3y plus 4y equals 4. 39 plus 7y equals 4. 7y, oh, this is 9, equals negative 35. And y equals negative 5. And then you can take and plug it back in to what we solved for x, which is this. X would equal 13 plus a negative 5, so minus 5, which is 8. If it had asked you to graph it, it just said to graph to check, but let's say you did that. You would have to get them both in a slope-intercept form. So the bottom would be y equals, well, it would have been negative y equals negative x plus 13. So y would equal x minus 13. That's the bottom. And the top would be 4y equals negative 3x plus 4 divided by 4. And y would equal negative 3/4 x plus 1. So the top one would start at 1, and you'd go down 3, 1, 2, 3 to the right, 4, 1, 2, 3, 4. And you draw your line.
Is there going to be a graph or do we have to draw it?
There's a graph.
How many graphing questions are there?
1. And then the second one is y equals x minus 13. So I'd start at negative 13. And I'd have to keep going up 1 and right 1 and up 1 and right 1 and up 1 and right 1. And eventually, it would be here where they would cross. And that coordinate point would be 8, negative 5. So if as it was, it didn't cross, I would just keep going 1, 2, 3, 1, 2, 3, 4, and then it crossed. You can check it. Sorry, hang on 2 seconds. If it said to graph and you have the graph and then you have the time to check it using a different method, go for it. You could even take that point, plug it back, and make sure it works. But you will not get credit with the question on the graphing if you don't have the graph. Yeah.
So there will be times where they tell you what you have to do.
That's only that.
Only the graph.
Mm-hmm.
Okay.
Jason.
Is it, no solution when they don't cross?
It would be no solution if they didn't cross, yeah.
So can I just use substitution to find the point and I don't have to put like a bunch of points like lined up?
You have to draw the graph.
No, after I draw the graph, like just a normal line through the point, right?
You mean to check it, use substitution? Sure. If you have the time though, because you're just doing that problem twice. If you have the graph, I would find the graph, find the point, move on, and then if you have time at the end, go back. Yeah.
Would that just be no solution for the graph because,
No. Just because they didn't initially touch doesn't mean they'd never touch. A no solution would be if they're parallel.
yeah, so would that just be no solution for the graph? Like, so if it didn't touch?
No, you have to extend it until it does touch. If it does, eventually, those are lines, so the lines go on forever.
Okay, so the ones that we do actually do, right, but we don't use a graph, we wouldn't know if they're no solution or not unless we graph them.
So from an equation, you can spot that they're no solution if they have the same slope but different y-intercepts. Those would be parallel lines. Okay, 18 says being invested $30,000 in two separate funds. Fund A pays 3.5% and Fund B pays 4% simple interest. If Bean wants to earn $1,140 from his investments, how much should he invest in each fund? So pay attention to that because if it only asks for one, you want to make sure you cancel accordingly. So I know A plus B equals how much you invest, which is $30,000. And I know 3.5% would be 0.035, so 0.035A. Plus 4% is 0.04, 0.04B equals what you want to raise, which is 1140.
So is it gonna be set up that way?
I mean, it's the same two types of information you've gotten every single time. Like in the world of word problems, are there other ways? Yeah, but these have been the same way. So I want to get rid of the decimals. I'm going to multiply everything. I have to multiply by 1,000 to get rid of them because you got to move it three places. So this would be 35A plus 40, because 1, 2, 3, 40B equals 1140 and 3 more zeros. So 1,140,000. Now I'm working with this system here. You can do elimination or you can do substitution. If I wanted to, so at this point I would make sure, like if this up here said, how much do you want to invest in Fund A, I would cancel out Fund B. If it said how much you want to invest in Fund B, I would cancel out Fund A. But because it says both, it doesn't matter which order we do this in. So if I multiply everything by -40, just because it's easier with a 0 than with the 35, I'd end up with -40A minus 40B equals, and then 30,000 times 4. I'm going to multiply the coefficients, and then there would be 1, 2, 3, 4, 5 zeros. And it's negative because it was -40. And then combine that with the first one, 35A plus 40B equals 1.14. Combine these, I get -5A, these cancel, equals so it'd be 60,000, -60,000. And then divide both sides by -5. And A is 12,000. Since they add up to 30,000, 30,000 minus 12,000 gives you 18,000 for B. Mm-hmm. Yeah, like I would plug it in here. That's the easiest way to do it. But you also know that just like that the two of them have to add up to 30,000. So you're basically just subtracting it from that 30,000. Yeah.
for some reason I forget that, could you plug it into the one below that?
Oh, yeah. But you're not gonna have a calculator, so I wouldn't.
You can go over 15.
Mm-hmm. Okay, Valerie, tell me how you started it so that I make sure we get the same new one, new two.
So the top one, I went -3, and I multiplied that, and I got -3x.
Wait, which two did you pick?
The first one.
The first one and the second one, and you multiply by -3?
And so I got -3x, -3y plus 15x equals -54.
It should be positive 54. So these cancel. And that's new one. Then did you do 2 and 3? Well, what'd you do for the next one? 3 and 1, making one negative?
Yeah, I did 2 and 3.
Oh, you did 2 and 3, making 3, multiplying -3.
Yeah.
Okay, then you've got new 1 and new 2. If you multiply new 1 by -2, the y's are going to cancel. And these 3. And then you got to plug it back into one of the new ones. So if I plug it back into the first one. Y is -2, and then you got to plug that back into one of the first ones. So if I pick the very first one. Mm-hmm. I don't. It's broken. -1, -2, and 3. I mean, I don't know if I would have picked the last one. I would have probably done 1 and 3, but you eventually have to get new 1 and new 2 anyways. Sometimes you get lucky. You could have done the y's. Yeah, you could have done the y's. You would have done 1 with 2 and multiplied 1 by 3. And then I would have done 2 and 3 and just canceled. Okay, so A was A, B. And remember, the order of the letters is important. If that was reversed, I literally have to rewrite it in order for my brain to see it the right way. So that the left is always on the left and the right's always on the right. This is a 3 by 3 and a 3 by 3 because the middle 2 match. It can be done. The outer 2 are your results. So this is going to be a 3 by 3.
Can it possible be an answer on a test?
Yeah. So the first one would be row 1, column 1. Row 1, column 1. Row 1, column 1. So 1 times 0 is 0, plus 0 times -3 is 0, plus -1 times +6, which is -6. So this one's -6. Then it's row 1, column 2. Row 1, column 2 would be 1 times 1, which is 1, 0 times -5, which is 0, -1 times -2, which is +2, and that's 3. Row 1 times column 3, 1 times 2, 0 times 3, -1 times 4. Then I go to row 2. Row 2, column 1, 0, -6 plus 0. Row 2, column 2, 4, -10 plus 0, -6. Then row 2, column 3, 4 times 2, which is 8, 2 times 3, which is 6, 0 times 4, which is 14. And then I go row 3. Row 3, column 1, 0 minus 9 plus 30, 21. Row 3, column 2, negative 3 minus 15 minus 10, negative 28. And row 3, column 3, negative 6, positive 9, positive 20. Remember I said I would practice that on paper at least once because tomorrow, you've had a very different experience if you've been doing all that only on Notability, right? Because you can highlight, you can circle, it's different. You can use colored pencils tomorrow, but once you circle, you can't erase. So it's not like you can undo it. I don't have erasable colored pencils. So just keep that in mind. I would practice the multiplication without, like on paper, without a digital device.
So if that was the A, you would move B's to the other side, and A to the other side. and then you-
I do. Like, I literally switch it. Yeah, because I think it's harder. Your brain is starting to train it to go left to right and then up and down. So if you have to switch it in your brain, it's harder.
Okay.
When it's like this and it's already like y equals, it's easier to use substitution.
Yep. So I would say be flexible. If it's already solved for a variable, use substitution. And then if it's lined up, then use elimination. Sometimes it's neither and you got to figure it out. But I would say be flexible. Don't only stick to one method.
So from the column, the row, you gotta go from so rows are horizontal.
Horizontal, yeah. Think a column, think about a column on a building, right? It goes up and down. Yeah. Other questions on the review?